So soil is composed of, you know, different types of particles. So you have the mineral particle from that weathered bedrock, and then you also have organic material. Um, Actually, let me go back. Maybe it's not bedrock. It could be also any other rocks that are deposited there. Um, by the other ways that we had talked about. Um, so, um, so by wind, water, glaciers. So anyway, like I was saying, the weathered rock itself, so whether it's bedrock or rock that was deposited, right? So you have minerals. The other part of it is organic material, and so that's humus, really dark, rich, organic material. Um, and then you also have, and depending on how saturated the soil is, you have water and air. And so in this diagram, it says 25 and 25, but depending on where you are in the water table and any recent rain events that you may have had, those percentages are going to change. But, it's important to keep in mind that those pore spaces are composing 50% of your soil. And so I just said the word pore space. We've used it before, but porosity is how much pore space there is. So if you look at really super saturated soil, so like in the water table, most of those pore spaces are completely filled with water, where in really dry soil, you actually end up with just mostly air. And so that's really important to remember, that those pore spaces are very important when we talk about properties of soil. And so um, we need space between soil particles because plants that are growing do need air, right? They need carbon dioxide for photosynthesis and they need oxygen for cellular respiration. So plants actually do need air within the soil. Um, like I said, most of it is, or about half of the volume of soil is pore space, and these spaces allow water and air to travel through. And so, pores, the amount of pores that are present in a certain type of soil will actually increase the water holding capacity. Whereas if I have less pores, I will decrease water holding capacity. So how much water the soil can actually hold on to. And so the rate at which water can kind of filter through the soil is called permeability or infiltration rate. And so this is the rate that water and air can move from the top to the bottom. So if I were to pour water on top of these larger particles, it would actually come through very, very fast. I'd say it has high permeability or a high infiltration rate. Whereas when you have very, very small um, particles, it's you have low permeability or low infiltration rate. And the reason why is because these spaces are very large, and so you end up with these the water is very easily the water can easily pass through these spaces, whereas when your soil particles are small, the water has a harder time getting through, so it'll actually hold on to the water, or you'll have a high this is a high capacity water holding capacity, and this would have a low water holding capacity and with a high permeability or high infiltration rate. And so when we look at particle size, as you can see, it's very important. And the difference between particle sizes is just their size, and that's it. So sand is the largest, silt is in the middle, with clay being tiny, tiny. And so we can actually determine the texture of a soil depending on how much sand, how much silt, and how much clay there is. And so you guys know this soil triangle well, I'm sure, but are going to figure out how much sand along this bottom portion here, how much silt along this side, and how much clay. And where the three lines meet up, you end up with the definition of what your soil texture is. So, for example, loam, which we know is the best for agriculture. Um, and so again, right, this is like big, small, smaller. Moving on. And so the relative proportion, again, like I said, right, is big, medium, small. Okay. And here is our soil triangle that you guys know. So I'm not actually going to waste any time on this. So depending on what soil texture you have is going to affect the soil properties. So something with very large particles, like a sandy soil, is not going to hold water well. It has a low water holding capacity. And fine textured soils has very poor drainage or a low permeability or a low infiltration rate, and it has a high water holding capacity. Clay is super special because has um, it actually has the ability to hold on to certain ions, and that's really important for plants. And so the clay particles are actually increasing the soil's ability to hold both water and nutrients. And so the clay is negatively charged, and it holds on to these nutrients that are so important to plant growth. So here's our charged particle again. So just to reiterate, you have infiltration, which is the downward movement of water through the soil, or like we were saying before, also permeability. Leaching, which is the dissolving of minerals and organic matter and carrying them into lower layers or surrounding layers. And the soil type is going to determine how fast or slow these happen, how fast things infiltrate, and how fast or slow um, matter actually leaches out. And so all of this is going to affect also the pH. And so the pH ranges anywhere from 4 to 8, depending on your soil. And so some are extremely acidic or basic. So those are exceptions. But depending on what is optimal for the organisms that are there, that's what your soil is going to be. And so we've talked about pH before, that pH is the number of hydrogen ions, and so the lower the hydrogen ions, the concentration of hydrogen ions, the more basic it is, or the higher pH it will be, and vice versa, right? The more hydrogen ions you have, the more acidic it will be, the lower the pH. And so if things are too acidic or basic, it's actually not going to allow compounds to dissolve, and so you may not allow for certain ions to exist, so the plants are not going to be happy with that. And so there are things that you can do if you have a bad pH in your soil. If it's too acidic, you can add limestone. If it's too basic, you can add some sort of organic material. And so here is nutrient availability. You can see right in the middle there, lots of awesome nutrients for the plants, but you get too basic over here, too acidic. The nutrients just aren't going to be available in the soil. So our soil nutrients are important for plant growth, as you well know. And so our macronutrients are nitrogen, phosphorus, and potassium. And so on any bag of fertilizer, you're going to see the NPK content. And because those are the nutrients that are very important in plant growth. But the smaller atomic ions that are there are called micronutrients, and plants still need them, but they need them in smaller amounts.